happy to be here with all of you. So for the next 1 hour and 1 hour, I will present two things. First, I will talk about causality, and second, I will show you my paper, but really preliminary results. And the idea is really to exchange with you about those results. I'm really looking forward to hearing your feedback on those really recent results that we have. But first, what we are going to see and what I'm going to discuss with you is about causality and causal inference, which is first my passion, my expertise, but even also further than that, my obsession. And let's see why I find this really exciting, and hopefully let me take you with me in this fantastic world that I love so much. So first, who the hell am I? So I'm doing empirical research using inferential causal inference to assess causal effects of different questions. I worked on a varied set of questions. So for example, what's the effect of sending weapons in Africa on the probability of conflict? What was the effect of the COVID lockdowns on the spread of the virus? And numerous different questions. And today, also why I'm here, it's because I have focused more and more on the environmental crisis and working more specifically now on the energy transition. Beyond doing research, so now I'm a postdoc researcher at EPFL and the University of Lausanne, and also lecturer. Beyond doing research, I also love teaching, sharing knowledge. I'm doing this in academia. I've done this for the last 10 years. But also a lot on social media, and hopefully we'll be able to connect and share, exchange on those medium later. So,
can you say a little bit more about your affiliation and Enterprise for Society?
Yeah, exactly, that's a very good thing. I had it in the back of my mind. I didn't want to take more time, but I think it's good that we speak about this. So I'm part of Enterprise for Society, which is a joint venture between UNIL, University of Lausanne, EPFL, and IMD Business School. So the idea was really we had three leading institutions in the same place working on similar issues, partly the environmental crisis. So we decided to join the forces to do applied research mostly and to try to spearhead the transition to a more resilient economy, to a more sustainable economy. Really with applied research and connecting to the world outside academia. That's really what we are doing there.
Thank you.
Thank you for the question. And at any point, please raise your hands, ask a question. That would be really great if we have an exchange rather than just me speaking here today. Why causality? Why is it so important that I always claim that it might be one of the skills that you must master even if you're doing not research at all? Well, because most of our decisions at the individual level, firm level, politicians rely on causal chains. We do things because we think that it has some consequences. Most of the time we assume those causal chains. It might make mistakes. So I put some examples. Like, if I go vegan, will it help to reduce my footprint? If I drink this additional shot of vodka, will I dance better? If I keep spamming on YouTube users with YouTube ads premium, will it increase the subscriptions? Should I force people to work on the job place rather than at home to increase productivity? I have many questions also related, tough questions, to the environment. Should we stop producing nuclear energy to reduce and reach the Paris agreements? Well, those are really difficult questions. And they all assume causal effects. So it's really important to know if what would be really causal effects. And indeed, I'm a trained economist, as Jan said, and we are absolutely obsessed with causality, and there are good reasons for that. Mostly in economics, you try to often conclude and find policy recommendations. You want to find advice in the end, what should you do to impact the world, the behavior, maybe emissions. But to do so, you really need to know the causal chain, right? If your analysis relies on correlation, you might go very wrong. Let's take an obvious example. You witness that people drowning have sunscreen. and then you ban sunscreen. Makes no sense, right? This is very obvious. You have some situations where policymakers might fail to properly assess the causal effects and then take the wrong decision that in the end are even more costly. So, and you have tons of examples like this that are problematic, that I see every day. For example, here, I'm not going to cite the person, maybe you know who he is, but a really famous environmentalist in France tends to use aggregated statistics like this. So here on this graph, it's the global primary energy consumption for the world through time. It's not per capita, total energy consumption through time. And basically, he shows his graph in a very famous talk, viewed more than 1 million times on YouTube, and claim, well, we said, that cities will reduce emissions because you will be closer to your workplace, to where you eat, where you do sports, and your home. So you reduce the transportation, the distance you move, so it might reduce the emissions. And then he shows this graph as if you can conclude anything with this, saying, well, we see nothing happen. If anything, it's getting worse since the 50s, it's exploding. While we also have the boom of cities in the 50s. That makes no sense, right? You have many things changing at the same time. At least take into account that you have population growth at the same time. So to observe what's the effect of cities on emissions from transportation, you have to go way deeper than these aggregated trends. Here, it's impossible to get the effects. And again, the other day, in a local journal, I see journalists using results from scientific research. The paper is really clear. In the headline, the title of the paper is like association between naps and cardiovascular diseases. It's really in the title. It's an association. They see that there is a positive association. You tend to take more naps when you have more issues with your heart. And then it's in the 20 minutes, they say basically, you should not take a nap, this is dangerous. Maybe consider stopping this. Again, that makes no sense. It's completely driven by, yeah, go ahead, please.
Yeah, when you pronounce the word association, does it have a technical meaning for you?
So it's a very good point, often debated. So I would substitute here correlation, but when I use association, it's not necessarily a linear relationship. They are related in some way.
I see, I get your point.
That's a very, very important precision. And so again, that makes no sense. It's mostly driven, at least at the same time, by what we call reverse causation, right? It's because you're sick, you might be unhealthy, you need to take rest, and that's why you take naps. So by stopping taking naps, it will not solve the issue, it's rather the opposite way. So that's why it's really something, a tool that's important in research, but even in daily life when you hear politicians read the news, debate with others about their research. So, bottom line. And hopefully this will speak to you as mathematicians. Why is it so hard to assess causality? Because actually you don't have a statistical test that will tell you this relationship is causal. There is not a test that will tell you this. You can do many things to assess causality using statistics, but you cannot usually test what we call the identifying assumptions for the causal effect directly. You can test assumptions around this or getting close to that. And that's the tricky part, is that math is not the only thing that can solve the issue. You also have to use your knowledge of the field, of the question, and put this together to think about why is it causal and why it might not be. And that's why I also call it the science and art, because you really have to think in a broader term about those questions. And I find this really exciting and fascinating. So, just to be sure that we are all on the same page, let me really go to the bottom line of causal inference. So, to illustrate this, what's the core of the idea? Let me tell you a very small story to illustrate this. let's say you have a headache. You're not sure if you should take a pill or not. So if you do, you wait a bit. It gets worse. So in the end, you decide to take the pill. And after a while, your headache is gone. But if you're like me, then you start frowning and you're like, was it really the pill? Or was it because I drank tea or plenty of fluids, or just because time went by? Well, obviously here, it's absolutely impossible to know, right? So many things are moving at the same time, and you'll never know for one anecdotal situation like this if it was the pill or not. And this is what we call the fundamental problem of causal inference, right? The only way to perfectly assess the effect of this pill, causal effect, will be to have two parallel worlds. In one of the two worlds, you take a pill, in the other you don't, or you take a placebo. And only in this situation, everything else is equal from the Big Bang to your headache. Eventually, if there is a difference, it might be most certainly causal. That's why it's called the fundamental problem of causal inference. Basically, research focused on this is doing its best to replicate the parallel world story. But that's really the key. We are never exactly there, even with in vivo research in medical research. And spotting the difference between the potential parallel worlds with what you have in research will really help you to question causality, even in published papers, when sometimes they claim that the effect is causal. So the usual, what we call the gold standard to address this is to use randomized control trial. You basically take your sample, hopefully representative of the population, you randomly allocate them between the two groups, and hence, they didn't have any decision in taking the pill or not. They usually are blinded, so they don't know if they took the pill or the placebo. And then, if there is a difference, it's close to revealing the causal effect because you have something similar to parallel worlds. But of course, why is it interesting? If it was so simple, they would have a general answer and solution. It's not the case. Randomized control trials are by far not perfect. There are two main limitations. First, often we cannot do this. We cannot always do this in some situation. For example, I have this paper assessing the effect of sending weapons on the probability of conflict in the destination country. You are not going to randomly send weapons in sub-Saharan Africa to see if the probability of conflict increases, right? And in other situations, it's just impossible to do. You're not going to manipulate the gender to see the different effects on different outcomes. You can do on a CV, but in many situations it's not possible. And the other thing is that usually in randomized control trial, you control perfectly well the environments. So it's very similar. But then, as you control perfectly well this environment, sometimes it comes at a cost. The cost of external validity. To what extent can we conclude beyond the scope of the study or extend the conclusion of this study? Well, there is a pretty interesting or funny paper, which is a true paper, not a hoax, published in BMG. So, what's it about?
So what is BMG?
It's a British medical journal, a really serious journal, medical research. And what is it about? Basically, it's a randomized control trial. It's not a hoax. Let me walk you through what they did. So, randomized control trial, they did an experiment between 2017 and 2018. They managed to enroll voluntarily, so only people volunteer to do this experiment enrolled. There were 22 people that enrolled voluntarily. The treatment was having an empty backpack or a parachute. And it was unblinded, so the people knew if it was an empty backpack or a parachute. And then the outcome, so what they observed, it's the probability of death or major traumatic injuries after jumping from the plane. And where's the catch? Of course, that's the catch. But that's a true story. Yeah, go ahead.
Can I guess?
Yeah, sure.
The people with the empty backpack just jumped from the plane after it landed?
So that's very close to this. That's a very good point. So he suggested that people jumped after the plane landed. Actually, it's very close to that. What they did is they could only enroll people on small stationary aircraft on the ground. So basically, the plane never left. And the idea of the paper is really to raise awareness of those issues with randomized control trial. That's, you control perfectly the environment, but it might not reflect well reality. Maybe another cool example about this, and it's slightly more serious.
But sorry, but since the controlled population, probably nothing happened to them.
Exactly, they find no difference.
Yeah, so then parachute use, so what's the answer is that parachute use doesn't really prevent anything.
Exactly, so in the paper, the conclusion is that parachutes are useless, but the main point of this paper was to raise awareness about external validity, but you're right, they don't find any difference because people were jumping like half a meter. So if you look, they really did this. It's in the Christmas edition of BMG, because for Christmas edition, basically they accept real research, not kind of fancy research. And I have another example that
Ig Nobel Prize.
with external validity. Very important question that we might all question at some point, either as students or teacher, when you're studying. Do students learn better if they are closer to the teacher in a room, in an auditorium? And here, they basically, it's let me start with a pretty decent journal, +1. Very interesting here, that they really say that people seated further from the teacher, it negatively impacted their learning abilities, and they measure this with their tests. This paper is only observational data. So clearly the decision to sit behind is completely endogenous, and it's related to many different things. So there's nothing causal about this, but the wording in this pretty decent journal, +1, really implies causality. This is quite shocking. You can really read the paper and you see that they try to do things, but there is no randomization, not enough control to be sure about this. And then, basically, you have the perfect, in some way, the perfect randomized control trial to address this question. What do other research did in another journal? They do an RCT, where basically students were randomly allocated to different sitting positions in a virtual reality room. So they use VR masks. So then everything is the same. Same view outside, exactly same room, exactly same words from the professor, but they are randomly allocated in front and in the back or in the side. And then they look at how they answer to an exam. What they find? They find, well, that people seated at the back were doing a bit lower, had lower results. But here I think they miss kind of the point. What happened when I was sitting in the back of a room? What I was doing, I was not only far from the teacher, I was speaking with my friends, using my mobile phone, reading something else, my emails or something. And here you take all of this away. So you don't really, it's really hard to say that we care about virtual reality, because in reality we are not in a virtual reality room. And you can really question this external validity and the validity of those results.
Even
what is the point of using virtuality in this context? Because they can take like real classroom pupils and try to make things.
So I think it was more complex. Virtual reality really allows to perfectly control the environment. You're sure that it will be exactly okay, I see what you mean. So for example, they took, that's a good point. I mean, I would trust way more this experiment actually. You take one class, randomly allocated people to sitting position, and they take the test at the end. I would check the rationale for this. Yes, go ahead, please.
Of course, it's a bad analogy, but for me, it's okay. You want to control perfectly biology experiment, so you replace the plant by a virtually simulated plant, and say, oh yeah, we have observed that.
Yeah,
of course, not the case because we have real persons behind the computer, but it sounds very strange.
I mean, I will read the paper fully to understand the rationale for virtual reality. I agree that you could perfectly do this with just a room, one class, where you're randomly allocated. I'm sure there is a reason, but I honestly don't know it. Okay, so then basically we have seen sometimes it's not possible to do an RCT. So what's usually the things that I'm doing? I'm preparing RCTs now, but most of my research was using what we call natural experiments. What are those? Basically, it's when in nature you have situations that will kind of replicate what you will do in a lab. And arguably, conditionally under controls and what you can control, randomly allocate the treatment between two groups that are comparable. And let me give you an example with this. If you want to assess the effect of pollution on health, on lung disease, you typically don't want to expose humans to lethal level of pollution. But you observe this in nature. So you would like to see really in reality, not only using animals in info labs, what is really the impact of pollution, reasonable amount of pollution on health on the long term. So what they did is, for example, you look for a shock in reality that will kind of randomly allocate the treatment. So again, if you compare, let's say your initial idea, let's compare the risk of lung disease between people who live in a city and people who live in remote areas. Well, again, many different things that varies between the two groups. They are not really comparable. They are not only living in a city in a remote area, maybe they eat differently, there are different activities, different kind of jobs, different age, many things change. So not possible to compare the two. So what they did is actually during the Olympic Games, or one example, is during the Olympic Games in China, the government really imposed strict policies on the city and around to reduce emissions, to clean the air during the Olympic Games. So suddenly, you have an exogenous shock. You live in the city, and you can really compare the same people before, during, and after those reduction of emission and their risk of lung disease. But this is completely unrelated to those individuals. Just because there is a sport event, suddenly they are less exposed to pollution. But they keep doing their job, they keep with their choice of living in a city. So then it's really comparable. And that's an example of a natural experiment. I'll show you then another one related to this. So if you know the Rubin-Kozan model, it's summarized here what's the main issue. But basically you have three things that you look at that questions causality. It's reverse causation, omitted variable bias mostly. So is there something else? Could it be the reverse as well? And the last one, which is non-classical measurement errors. I can talk about this at the end, but it's less often that we face this. It's when you don't measure perfectly your outcome, and the mismeasurement is related to the relationship you're interested in. I can show you an example at the end. So basically, if we cannot test directly for causality, what do we do and why is it so exciting? That's really the thing I wanted to share with you. It's exactly what a police detective is doing, right? They have suspects and they try to find if they committed the crimes. It's very rarely the case that you film the person doing the crime, and even if it's the case, maybe the video is blurry, maybe it's a fake. So you're never completely sure. What you do is basically you check for the alibi of the potential perpetrators, culprits, and then you try to discard those different alibi. And then you look for other potential criminals and see if they have an alibi or not. And you repeat this until you accumulate enough evidence. But you usually don't have a proof. You just accumulate enough evidence. And that's exactly what you do in research. So last example before we jump to the other paper, my current work. Important questions. Sure, pollution affects the environment, no doubt about this, but also directly our health. And sometimes it's a good angle also to take people on board. It's directly killing yourself. And that's in 50 years. And for animals in remote areas, it's really affecting you today. It helps with some humans to react. So this paper, published in 2018, was about measuring the effect in London, a retail city, using 100 years of data. The thing is, in the 18th century, basically they didn't have much precise data on air pollution. So what the person is doing is the following. Well, London is not really well known for the nice weather. So what he's using is actually when it's foggy, it keeps the pollution low and high pollution level that people will be exposed to. And actually, we have very precise data on fog for 100 years in London and more. So the idea of the paper is to observe what's the effect of fog on mortality. And here again, this is basically the suspect is that it's pollution. Now we have to be sure that it's not fog is related to something else. So how do they deal with this? How does he deal with this in this paper? Well, first, let's look at how things vary through time. So here we have the seasonality of fog. Basically, we see that it happens mostly during winter, end of the year, beginning of the year. Those are weekly level. And on the long-term time trend, we also see that in the 19th century, you have a lower probability to have fog. So you want to control for all this, because you also have like medical knowledge and system that improve through time. So that will increase the observe or bias the effect we want to observe. Here, when it's colder, people get sick more easily, so it will not be a story of pollution, but of just getting sick due to cold weather. So you want to control for all this. And here is basically main results. So first, it's using a linear regression. Very simple here. I replicated the result using Python. So it's just a forest plot with the coefficients. Before heavy fog events and after up to 5 weeks. So what we see is basically you have an increase on impact. When you have fog, you have the overall number of deaths in London that increases. But many things correlate with this. So then let's capture a time trend with year fixed effects. Let's capture the weather conditions as well, like cloud coverage, above, rainfall, temperature, humidity, all those things. And then what we see is that, okay, there is really a jump, more death, is statistically significant on impact and the week after. Now we can really ask, but is it really a story of pollution? That's really what you should do when you see this. Is it really a story of pollution or is it directly fog? For example, when you have a bad weather, maybe it increases accidents on the road, or maybe you have more crime because people can hide, can live, and it's easier. I don't know, but it's a plausible story, right? So what can you do to answer this? Well, you cannot say this is causal. What you do is that you try to discard the other stories. So you go and you look by type of death. How does it change? And here I compared accident with pneumonia, so data from the paper. And what we see is that for accident and crime, actually it's together, accident and violent crime, no effect on impact. So this is not the story. This is at least not the main driver. We cannot observe this effect. While for pneumonia, what happens? It shoots up on impact and the week after. So it's going in the right direction. Still, last example that I will take in this fascinating paper. Another alternative story, and that's typically how it works. You try to present your paper and everybody comes up with alternative stories and you have to discard all of them. Alternative story will be, well, when you have bad weather, what do? You stay at home. Stay at home, you spread your germs, you exchange, everybody gets sick. Maybe you don't want to see yet the doctor because it's cold, because you have bad weather outside. Maybe it's harder at the beginning for the doctor to come. So it increases your risk of dying just because you have bad weather. But it's not a story of pollution. Okay? Let's try to think how to solve this one. The author did something that I found really elegant. Basically, he compares the shock on death of heavy fog against another weather shock, heavy rainfall. And why is it really elegant? Because rainfall will have similar effects with the narrative I just told you. You will stay at home, you spread germs with your relative, maybe it's harder to go see the doctor or the doctor fails to come early or quickly. But the main difference is what's the effect on pollution? Fog keeps the pollution low. Rainfall cleans the air. So if it's a story of pollution, what will we see here in a moment it's opposite pathways. Fog, lethality shoots up, rainfall, it goes down. And here, it's typically one way also to discard those things. Again, you keep piling up evidence going in this direction to reassure and say, okay, it might be the causal effect. Yes?
Isn't fog predating rain? Like, is there
So the thing is here, indeed, they are correlated, but the thing here is that you can control, I control the guy as well. I control for rainfall. So it's keeping fixed the level of rain, but indeed, usually you don't have both at the same time. And here, it's in the same week, it's aggregated at the week level, and we only compare like high fog with low, with high rainfall. So I think it's pretty safe, even if it's correlated, the fact that you control for it should allow to disentangle the two. Okay. Let me take a look. Perfect. So that was it for this introduction of what I found fascinating in causality. I'd be glad to exchange with all of you. Oh, yeah, sure.
Just a quick question. It seems when you explain it that kind of the imagination of yourself or your audience is the limiting factor of coming up with alternatives. So there are situations where maybe the true explanation is you're not even able to imagine it. It's a completely different story.
Yeah.
I guess that's something
So
it's hard to deal with, right?
So I agree with you. So basically the way I see this is, if it's really out of the imagination of everybody you met who know pretty well the field, it might be random and you always have this issue, right? It's the type 1 error. You always have this, maybe something that's really unrelated or in some really intricate way is driving the results and you don't catch it. You accept this risk in statistics, right? You always accept this risk. So I think it's true. And that's exactly why in economics you end up with you take maybe often it happens 10 years to publish a paper and it's hundreds of pages because it's exactly what happens. You go to a seminar, you have 10 different stories, you want to address all of them, then you end up, you send it to a journal, referees comes up with other weird stories, you have to address them, and then it takes so long and you have like many things to discard those stories. But exactly, I think that's always a risk, but it's common to the field of statistics where you accept this potential issue. Yeah. Go ahead, please.
In fact, it's also common in other sciences. I mean, maybe not in a such strong way, but when you try to explain phenomena, you do it with the models you are able to imagine at this time. And at some point, you find experiments which make them false, or you have to find something more. So it's
yeah, it's quite. That's true. That we can generalize this as a problem. Our imagination might be a limiting factor and knowledge of the field. But what I think interesting is that here it's also cool to know that math are incredibly useful to do all of this, but it's also your knowledge is also incredibly useful. And that's what I find really cool in this field. Yes?
Sorry, a comment that just shows my age. Namely, when I was a kid in the 60s or teenager in the 70s, everybody knew that London was an unhealthy city. Actually, the fog was not called fog; it was called smog, which is a contraction of smoke and fog. Yeah. And so, I mean, qualitatively, everybody knew about the result. Okay, it's very interesting because it gives quantitative meaning to that. But
I think what you would say is really profound. Why do we want to assess the causal effect? Because it usually allowed to measure the magnitude, and that's what we care about. For example, my paper, so I just recently published this paper that I worked on 7 years, took 7 years to publish, and what's the effect of sending weapons on the probability of conflict in Africa? Well, very few people will argue that it has no effect or that it's not fueling the violence, right? But the issue is, what's the magnitude and can you prove the causal effect? Because lacking this evidence allowed actually lobbyists, suppliers to say, well, we are not causing the violence, right? Just when there is a conflict, people import more arms, and then maybe if you don't send arms, others will, or they will just kill each other with machetes. And then you really need to prove this, even if you have strong assumption about this, like Red Cross and all those NGOs knew that it was definitely causal, but we really had to bring like strong evidence, and that's why it's typically a paper that I discuss with all of those people, because it's really useful in their way when they argue, go against arms suppliers, arms dealers. But exactly, I think you point really to the essence, that you want to know the magnitude. And that's key, because maybe you know that there is an association between avocado consumption and health, but if you have to eat like massive amount of avocado to slightly change or reduce your risk, maybe you don't want to go this way. And again, that's why like really like p-value, it just, in my opinion, a necessary condition to interpret the magnitude, but we care about the magnitude of the effect. So just for the next 20 minutes, I think it will be enough. Let me just really share with all of you very preliminary, incredibly preliminary results. It's out of my computer like last Friday, and then I just put up the slides together. So the idea is really, go for it, give me feedback. We desperately need this, and it's not like solid research for the moment. I just want to share what's our idea so far, and how do we interpret those results here. So the idea is, Jean told me, like Julia presented a paper about how greening the energy demand, and now we're rather on the side of how to green the energy production. So, what is it all about? Very quickly, in 3 slides, what's the motivation of the paper? Well, energy production is definitely a huge, massive, main source of emissions, right? Here in 2016, it's 3/4 from energy production. But the thing is, it seems if you look at the world, if we look on the horizontal axis is GDP per capita, and then emission-based, consumption-based emission, we have basically 2 alternatives, right? What could be the case? Either we stay poor, or we emit too much. Fossil fuels really allowed us to become rich and to have vast amount of wealth. But what about renewable energies? How we can change this dichotomic situation? Well, we see 2 things about renewable energies. First, if you look at the footprint, so how much each really, with life cycle, emits emission in total when you use wind energy or solar photovoltaic against like coal or gas, well, the footprint is way lower. Those emissions are way lower. But the thing is, it seems that it's a better solution, but the use, it seems like a handful of percentage today. So why do we see such a slow adoption, despite the fact that the technology really improved dramatically over the last decade? And that's what we want to study. What's the relationship between technological improvement and energy production with those technology? So, sure, technological improvement makes renewable energy more efficient, so we should invest potentially more in that direction. And we focus here our analysis on 2 types of renewable energy, on solar photovoltaic and wind power, because they are fastest growing in the last decade, and they represent a larger percentage among renewable energies. What's the key aspect? Well, you know me a bit now, causality. The main thing here is, now we try to contribute to the literature, is really to assess causally this effect. How technology will drive this use of renewable energy sources. So what's our approach? Basically, as I'm going to show you the model later, we try to use only geographical characteristics of a country, which are arguably, again, exogenous, just geography. It was like this before, and it will remain mostly for a while. Jointly with technological improvement, like global technological improvements that are not necessarily driven by one country. And then the interaction of the 2 should be arguably exogenous to the system. It's really geography, you don't really affect this, and global technology improvement. Yes, please.
Just a question for the understanding. How do you find the technological improvement in the sense, or how do you measure it? What is it for you?
So very good point. Here we can use many measures. Here I will, for example, for photovoltaic, I will use the efficiency of the best cell, the best technology of the cell existing in the world in ERT. And then for wind turbines, we see it's just the size of the rotor. Because actually it's not trivial at all to increase the size. It's really related to technological improvement. That's our definition so far, but we'll gladly discuss this. And basically the idea is what's the relationship, the raw, global, aggregated relationship between technological improvement and renewable energy production, and then to look what might increase this relationship, like faster the implementation, or what mitigates the effect. Yes, please.
The best technology at the time T is probably also the more costly one.
So I
We
think
also have prices to take into account, right?
that's a good point. We wanted also to use the price in year T for certain amount of energy extracted. I think that's I have to think slightly more how it's. I guess they are correlated, but you are perfectly right. And when we see for solar, I think it's a very valid point, and that might be why we don't find much for solar.
Sorry, what's the point?
The thing
Oh,
is,
sorry,
I mean, you have the best, but the best is the max of your technology, but that's not the available technology for laymen, because the cost of the best is much more higher than the cost of the medium.
I see.
It's more expensive, so yeah, basically maybe you are not able to use it entirely, because first it's the end. Yeah, Jean, please.
I have another question. In the other example, we saw how to assess causality in the past, right? And now you want to assess, like, in the future, what is going to be the trend. But, like, how is it different? Is it really different?
So here then it's basically, your question is about, again, externality. Can we extrapolate to the future? Now we rather use observational data from the last decade. So really, for the last decade, what was driving? We can see it's also like backward looking. And we remain for this period. That's also why we want to focus on solar energy and wind power, because we already saw an increase. It's not too young that we see nothing happening. We can already see what might be happening.
So,
yes, please.
so the question is why it's so slow, but at what stage? I mean, I can tell you why it's so slow at an individual level.
Yes.
It's because it's too complicated. The question is too complicated. My 80-year-old mother who wants to install solar panels, the question is too complicated for her.
But is it the main driver individual investment, or is it like wind farms by the government? If we look at aggregated level of energy production, will it be really, because if it's at the government, that's typically a part of the story we want to check, is it a story of knowledge? And we check if when you have access in a country to more scientists, engineers that are able to implement those technologies, because we know that now there is really lack of knowledge and hands to put these things into practice. So it's part of something we want to check. Is the story about knowledge, and if you have access to this knowledge, do you do it at a faster pace? So that's typically something we try to check. So, very simply, we use a worldwide sample from 2017 to 2019 due to data availability, but also the time span makes sense because it's where there is really growth in those technologies. We use as an outcome wind energy capacity, production capacity, and solar energy capacity, production capacity. So here we are really happy to have the capacity because it's not endogenous in the sense, it's not because you have the capacity but then people use less so you can control how much you produce. Here it's really the maximum you are able to produce in 1 year. So it's really what has been installed so far. And also it's not affected by like weather for 1 year, which might affect other things. That's why we also really like capacity here. And then we will try to explain this, as I told you, with technology and geography. I'll go more into detail about those in a moment when I show you for both. So, let's go straight to the points. So who are those, just to get a bit of knowledge about the data, who are those who, it's not per capita, it's really aggregate level, so it's also related to the size of the country, who produce the most from wind energy. Well, you know that per capita there is definitely the UK, but we have Germany here, the US, and relatively large countries. That's where wind is produced so far. Or is it more a better idea to produce wind? Well, it's highly correlated with the latitude, right? Basically, the higher you go lower, you have higher speed. So here I used average wind speed 100 meters, because on the period the average wind turbine height was 90 meters, something like this. So so we use this average wind speed at 100 meters, meter per second.
100 meters over ground, I suppose.
Over ground, yeah. You're right.
I have a question. I thought that the speed actually of the wind is not like at some point you need to stop your windmill, or I don't know the name, for it not to break. So actually and it depends also on the one you use to produce the energy. So how using average wind speed is a...
It has limitations. If you have a lot of variability, it might be indeed it's not perfect, but it will definitely be related to the speed in the country and what you can extract. But I agree with you. It's not perfect if you have if this average is biased by extreme values, it's quite bad. So we should take into account, maybe if you have your hurricanes or things like this, into account, like really shocks. That being said, I will use a model and not restrict to have a linear effect. So I allow, when the speed is too high, to have like a decreasing effect. So maybe when it increases the wind speed, you are more willing to invest in wind energy, but when it's too high, it decreases. So I will allow for this in the functional form of the regression. But point taken, it's not exactly your question, I understood. It's really, if the average is affected by extreme values, preventing to really extract optimally wind.
No, what I mean is that when you have a windmill, you have like a range of wind speed for which it works. No matter like hurricane or not, it's really like you have a certain set, and your energy is not directly proportional to that. You have like a saturation point at which you cannot make your thing go faster.
So that's a little point. I think another measure that will be nice will be actually if I take the average or the number of days in a year where the wind speed was optimal. Yeah. I think we can look for this to reinforce the analysis. So I think it's a very good point indeed. So yeah. So for winds, we use the diameter for technology of the rotor, which increased dramatically over the years. So this is really the time trend, what we are exploiting. It's really how it evolved, mostly after around 2010, it evolved at a faster pace. And again, this is not trivial at all to increase this span. It's really, you really have to test this in labs, to reinforce the tower as well due to the weight, and test a lot of things with the material and how it will potentially break. So it takes a lot of time to increase this, and it's really related to technology. It's not just like, let's build something bigger and we can do it. From the first year, we could already do it. It's really, you have to do research. And for solar PV, photovoltaic, so basically, again, high correlation, basically where is it better to do it. Usually it's negatively related to wind. Usually, in some places you have the two options that are really optimal, but usually you can see like in the north, it's less optimal maybe to do solar PV. Back to your point, it's the same. When it's too warm, too much sun is also bad for solar PV. So it's also something we should take into account. Same for solar.
This is horizontal.
Oh yes, sorry. It's the total ray of sun that you can capture horizontally if you have like one pan that lays horizontally. It's rather this. It's how much sun you can capture. Again, this is only based on geographical factors. It ignores buildings, everything. The idea is really to have something that's just based on geography of the country. And then what's the highest, and also here something that we can discuss. I'm not sure if it's the best thing to do. What's the highest confirmed conversion efficiencies? And this is directly linked to the positively energy inputs, and this is the time trend. What did I use? What did we use to for this? We basically use this. It's a bit small, sorry. We see EFL here and many places, by the way. So basically, those are the best research cell efficiencies in the world every year, existing with different technologies. And I just take the upper boundary of this technology here. So that's the best cell efficiency in time t so far. And you have different types. So here, it's important to note, that's the sample start here. So it's really the last part of the graph that we exploit. And it's mostly the yellow, it's only the purple technology that we capture, because they are the top one, which is multi-junction cells and single junction. It's only multi-junction cells. So then we have also a question, maybe we should use like crystalline cells, because that's mainly what we might use in big farms. That's another alternative that we can do. And very quickly, because it will be time soon for discussion. So what's the model? We use a multiple regression model. It's very simple, very raw for the moment. We try to predict the log of energy wind production. Why? Because the distribution is highly skewed on the right. That's why we use the log transformation. And then in country I, year t, and you try to predict this well with an intercept. Then with average wind speed, with the rotor diameter, and mainly with the interaction of the two. Assuming that for an additional wingspan, meter of wingspan, you have a higher marginal benefit if you have also more wind in this region. But that's something definitely we can argue, and that I would like to discuss. And then we throw out some controls. For the moment, very basic one. We will plan to add way more to disentangle the stories, but just GDP population. Yes?
We saw before that the rotor diameter is very strongly correlated with the year. So how do you know how can you distinguish this?
Very good. That's a great question. So basically the real model we would like to estimate includes fixed effect. We don't have that now. So now, for multiple reasons that I can discuss later. So the idea will be to capture the main effect with fixed effect. Let's say, okay, we capture everything that's specific to this year, evolution of GHG, of climate awareness, of many things that happen. But for the moment, it's really raw, and I agree that it correlates with many things through time, because we saw that it's rather a positive trend. We have to disentangle this. What will be the main thing addressing this? Again, it might be population growth, it might be climate awareness, it might be price of fossil fuels. What would you suggest?
It might just be that people build more windmills and not destroy ones.
So it accumulates over time. So
Yeah,
basically, would you be? Yeah. So the thing is, fixed effects are really powerful, but then it gets a bit tricky also to interpret, because you will get rid of the main effect, which is also interesting to capture our story. So initially I started with this, but now I backed up with something more simple. I think something else that will not get rid of the main effect will be to have just a linear trend. For example, you control for year, as a linear coefficient on year. It will be a cheap control to go in this direction. Yes?
I think something going in his direction would be to ask not only for the change in the wind energy capacity, but actually for the rate with which this capacity is changing. So if we assume, like, I don't know, anyway people will build a wind farm every year, then to see whether you would be interested to see if this accelerates due to technology. So that would then be like looking at a first derivative of this wind energy capacity, for example.
Wind energy additional capacity implemented in ERT.
Your main variable is not the capacity, but maybe the change in capacity.
So that's very, very interesting. So
Right, Jeroen?
this is the first difference.
That fits with what you said, right? You can discuss later.
But yeah, again, point taken, I think it's a valid question to implement and check the results. And yeah, the levels are clustered at the country level. It's a basic standard way to do it with panel data because they might be correlated through time for each country. For solar energy, it's global horizontal irradiance times time trend I show you, best cell capacity in ERT, and the interaction. So what do we see? It's a bit smaller than what I expected. This is a plot because the coefficients, I don't show the tables because it's difficult to interpret because you have the main effect plus the interaction, so you have to do the sum and estimate the marginal effects at different level of one of the two variables. So what I do here is I take the lower average wind speed observed, the larger average wind speed observed, and I look at what's the marginal effect of moving by increasing by 1 meter the diameter. And then what we see is basically more you have wind, the more you increase the so it's always positive, and the more you have wind, the larger those marginal effects are. So it's really related to my initial rationale that both will positively affect how much energy you can extract potentially. Yes?
What is the unit of this vertical?
It's difficult to actually, that's a very good point. I made the point before that it was about the magnitude. So here, I should have to think a bit. So it's the outcome is in log. So then it means that you can interpret this as a semi-elasticity. So its change is in percentage. You can do math to properly measure this, but a quick way to understand it is like it's similar to semi-elasticity. So change in percentage. So it's 1 per 1,000 percentage if you move here. You increase by 1 meter, you increase by 1 per 1,000 the 0.1 percentage the energy capacity. A rather small effect if you increase by 1 meter, but let's say here the changes are quite big over time, so let's say by 10 meter, and then basically if you increase the wind by the turbine by 10 meter, on average it will increase by approximately 1 percentage the capacity you produce wind this year. Then I also, this model was restricted to be a linear trend, but obviously it's not necessarily the case, we discussed this. So I also allow for non-linearities here with a very simple quadratic model. We see that it's quite similar. You have it's definitely concave, so you have really reduced effects the further you go here, so it's interesting because it's also match what we would expect. Then,
Sorry, this is without controlling for a year.
this is without controlling for a year yet. You're totally right. It's the only controls here. It's very simple, very raw. It's population GDP. And then here we try to start with our story with a very simple approach, a split sample. We do the same regression for the countries below median by availability of scientists and engineers. What does it mean? I still fail to find, after reading the whole report, how they computed this. But basically, it's a scale from 0 to 8 of availability in a country of scientists and engineers. Whatever it means so far, I couldn't find yet before the presentation. And then basically, I look at the stock before the sample, like in 2007, and look at what's the effect for those who had already scientists and engineers above median, and those below median. And what we see is that the relationship goes a bit faster, slightly faster. Then we have to assess if it's statistically different, which I'm definitely not sure, seeing just the confidence intervals here. But it seems that if there is a statistically significant difference, that availability of this knowledge of those people help to reinforce the relationship between technology and implementation. And then basically we'll ask numerous questions in the same way. One other way to assess this is, or to ask this question, is what happens with disasters. If you suffered a lot of climate disasters in the 90s, so pre-sample, what happens with your rate of, how do you answer to incentive to implement more renewable technologies based on technology? And we see basically curious effects related to those below median who didn't suffer much, but most of the time it's not statistically significant because it includes the zero. So I really interpret this as it's mostly not much is happening, but we can like relax just the fact that it's a concave function and have a more complex function to see what happens exactly. While for above median, the one who suffered in the 90s, again, tend to answer at a faster pace. Yes?
So this is very interesting. So when there's no damage, the bigger the turbines, the better by far the scale.
So when this is when you have damages, when they suffered. Those are the one who
okay.
Yeah. So this is the one who suffered. Because usually that's something we see. It's when do people start caring? When it's affected. Most of the time. Is it policies? Well, most of the time the stronger shocks is really you have a drought in the country, you have forest fires, and people start caring because now they see it. They understand it's happening. Right? And that's why we're interested. Is it a story of policies, of laws, or just external shocks? And then we want to do like a horse race. You compare the magnitude of those. What's the most important ones? So that's basically the main idea. As I told you, it's super raw. Those graphs have been made 12 hours ago, more or less.
Sorry, I'm a little bit skeptical. It's like
I'm here for this.
you draw some graphs, and when it's what you expect, you say, okay, we expect it. And like in this left picture, when it's not what you expect, you say, maybe we should change our model. And then
You know, that's a very good point. That was really badly framed, and thanks for sharing this, really. I agree with you. Basically, it's when and that's true that we should be careful with this, and I should be careful with this. If the results match the narrative, it's not like we keep this, because then it's just data mining. So I agree, totally point taken. It just is so raw that I just spit it out, and then hopefully, basically, 6 months from now, I will take those models and have like 10 robustness test tweaks to be sure that what I'm suggesting is true. But I agree with you. Basically, the way I'm saying it here is not something that I will send, that I'm certain. It's really, I'm not sure what's happening here. I will have to challenge those results and see if it carries out here with the same challenges. But I agreed. I think it's important. Yes?
You were towards the end of your presentation? Because it was an end comment, but I wanted to like interrupt.
Let me tell you that basically, in very shortly, with solar PV, it's let me do it with solar photovoltaic, and then we close. But that's a good point. Just 5 minutes.
No, I didn't want to make the point. I just didn't want to interrupt your presentation.
No, but yet, let me show you very quickly like this. We still have at least 5 minutes to talk. So basically, this is with solar PV. So we see that's basically this interaction. More efficiency, higher efficiency, and higher GHG has positive marginal effects. So you want to increase the relationship. Again, we have to understand a bit more exactly what's this relationship, why it's inverted U shape. And then you have similar, so far, very preliminary results that basically the effect is larger when you have scientists in the country, and slightly larger when they suffered as well disasters in the past. So really raw things. I have also with the fixed effect things, but I don't want to spend more time on this here. We can, if you have a question on this. That being said, I took a bit too much time. Really thank you for being here. But first, questions. Let's discuss for the next 4 minutes.
Yeah, I can follow up. I was wondering about this main narrative. I think the main story here, or what your hypothesis that you try to test, is how big is the effect of the technology.
Yeah.
I was wondering, particularly for PV, whether it's the right thing to take the most effective PV at research level, which means kind of it's the state-of-the-art research which would influence, or whether it's not much more the production technology, the ability to produce a good solar cell at a reasonable price that will drive the capacity. Which is less kind of the state-of-the-art research, but the ability of companies in the country to really produce good PV
compared
cells.
to this, it's not the state-of-the-art efficiency, but it will be related to maybe what we said before. It was the cost per unit of energy.
Exactly.
Yeah. But I agree. I think cost per unit of energy.
But that's also the question you addressed before when it was the same that Ariadna
Yeah.
asked. Yeah. Okay.
Yeah, no, exactly. It's really about cost because you have different incentives. It's maybe available. It's incredibly costly, but at the end you will implement and that's the narrative behind or the hypothesis. It's if it's worth it, you will implement. Yeah. Maybe go ahead.
Well, what you say about availability and contradicts my intuition about. I live in Nice.
Yes.
We have plenty of scientists. We
Yes.
have sun. We've had more natural disasters than you can probably think of, and we have no solar panels.
What do you think happens here? So maybe it's just it's anecdotal evidence. So maybe something weird happened.
No, you can look at if you look at the
What is that?
distribution map of solar panels. There is maps of distributions of solar panels around Europe. You will see that there is a huge concentration, like in Germany and all those
Yes.
places that don't have that much sun. And if you go down to the coast in the south, we suffer a lot of all sorts of natural disasters.
Right.
We have a ton of scientists, at least in Nice. There is really a ton of
Yeah.
fences, but no solar panels.
So I think that's
Political.
interesting. So two things that how I think about this, maybe it's spread out over the France territory. But here you compare it with
No,
Germany.
you really see that north of France has much bigger concentration of solar panels than south of France.
Yeah, but in France, the north is flat and the south is mountainous, so it's difficult to put solar panels.
Well, you could put a lot of solar panels in Nice, you'd be fine, right?
Well, you could put them on roofs.
Yeah.
I think it's a political explanation. Who is in charge of ruling the region in PACA?
Rosie?
C'est impossible.
Estrosi is
The
the
mayor.
mayor of Nice.
Yeah, but that's kind of true over all the south if you look at the map.
But okay, south, it's Carole Delga is in charge.
I don't know.
Yeah, it's a bit complicated, but maybe there's some ideology also in that.
Yeah, there's probably some ideology related to it.
So definitely also a path we would like to explore how policies, even democracy, a broader term, is related to this. Yes.
Yeah, I just wanted to make the same point. Like, in my understanding, lots of the historical increases in renewable energy have been as a result of public policy, like in Germany, or also state investments by China.
So why Germany, for example? You picked the example. What's your thought about why Germany did
And
this?
they had billions of support for solar power to guarantee a certain amount of
So it
profits
will be
to
more a
investors.
left-wing thing, and they had left-wing governors, from what I heard.
I think it was introduced by Social Democrats and Greens initially, but yeah, this was also something which spurred the technological development of these technologies, in my understanding. But yeah.
So beyond democracy, we could look at like the importance of the Green Party in the country, something like
Yeah,
that.
like or just public policy support. I mean, now like different parties are there and they continue some sort of support, but like the feed-in tariffs, I think, were very crucial for the initial development. But
Thanks. You had one.
I have many.
We will be able to chat. Okay, so if you have many, I don't want to take more of your time. So it's a huge pleasure to be with you this morning. Thank you very much for the discussion. The feedback already very enriching. Again, one last thing, because it was really unfortunate I could not come for the whole week. So if by any chance you are interested to keep the discussion alive, you'll find me on all those places, mainly on LinkedIn, where I post daily about causal inference and things like this. So I gladly chat with you more about your research and thank you very much again for this.